So let's go add this world bounds aspect of what we need to do. To do that, I'm going to create another empty object here. And this is going to be our game world. And I put this in brackets. This is just telling me that this is not an actual renderable game object. This is just a game object that's going to hold either mono behaviors or component data that I want to be able to access and do something with. But it's not an object that is interactable or renderable. This is just my way of doing it. Whatever works for you guys, go for it. But we have this game world, and we need to go write some new components for this game world. So I'm going to go add a new struct, and we'll call this a game world data. And then in this game world data, I component data, as we've done so many times, add a generate authoring component. We're going to do that a lot. All right, so what does this need? What is this game world? What data do we need on it? Well, we want to have a bounds for the game. We want to know what the boundary of the world is, because right now there is no bounds. So let's create a float 4, which we'll use essentially as a rectangle. And that's all we need at the moment. I just want to know what's the bounds of our world. And when we get back in here, we can now add this as a game world data and a convert to entity, which again doesn't do anything. We just want to convert and destroy. So for our game world data, what's the bounds that are we going to have? We're going to define this as X is our left bounds, Y is our right bounds, Z is our top bounds. I'm sorry, Z is our bottom bounds, and W will be our top bounds. It's up to us to decide how we want to use these variables. It's not a rect. It's not left, right, top, bottom. We just get 4 floats and do with them as we see fit. I'm going to use them as left, right, bottom, top. So we have this bounds data, and if I hit play now, we'll get a new entity in the world, and it's a singleton, right? Game world is now a singleton. It's only one of them, and it has this game world data, which has this bounds information. And I want to go use that in our player when we apply our input system. To know if we've hit the bounds, should we continue being able to move left or should we continue being able to move right? So to access that data, we don't want to look it up in every for each, right? I just want to cache that data, just like we're caching float DT. Well, the easy way to do that, again, since we're using the component system, there's a lookup that we can do. So I can say game world data, game data is equal to this.get singleton of game world data. What this is doing under the hood is it's querying the entity manager for our world that the system's running in. And it's saying, okay, go find me all entities that have game world data. It's a query. Everything's a query. ECS is nothing but queries and then executing on the items of that query. That's what systems do. So we're doing a query here. It says, okay, go find me all of the entities that have this game world data attached to it, because that's what makes a game world data object. It's an entity that has this component and nothing else, or at least just this component. And get singleton expects there to only ever be one instance. This is our game. We know that there's only ever going to be one instance, so we can use the get singleton shortcut and access that data. We're not accessing the entity. We're basically saying find the entity that has game world data, and then go access the game world data of that entity and give me back a copy of this data. It's important to know we're dealing with structs. Remember, all components in the ECS system is a structure. It's a struct. Structs are copies in .NET. A struct is a copy. It's not a reference like a class is. If I was to go in here and modify game data, if I was to say, okay, game data.bounds.x is equal to 0, the compiler and at runtime, it's not going to complain. It's going to let me do this. This is valid. This is valid. But all I'm doing is editing the copy of this game world data, what's actually lives on the entity does not get updated. Because remember, this is a copy of the data. So making changes here doesn't update anything. If I wanted to write this data back to the entity, to the component, I could say singleton, there is a set singleton, and we can pass in game data. And this will basically do the same thing. It will go find the entity that has a game world data on it, and it will then overwrite that structure with this copy of the structure. So that's how you can write the data back. We're not needing to do that, but just as an FYI, remember components are structs, and in that world, they are by default read only. If you make changes to them, they don't get updated. And that actually that's true when we're doing this for each in our entities here, unless we add a reference. So now this, since translation is a struct, I'm telling it that I want a reference to my translation position. And then in here, since I'm now modifying the position, I don't have to write it back on my own. The underlying system will make sure that that data is written back to the component of that entity, because I'm telling it that I want a reference. I'm telling it that I'm going to write to this data. If I were to use the in keyword, depending on certain situations, that would be telling it that it's read-only data, and I'm not going to write back to it. By default, this is essentially what you use. So now we have access to all of our game data. We have access to the bounds. So we want to clamp our position. We know that we can only move in the left or right position on the x-axis, so we can just clamp to that. So I can say position.value.x is equal to math, and this is the new math library. This is math.mathematics. It's a package. This is the new math library. This is not mathf. This is not Unity Engine Math. This is the new math library, which takes in floats 3s and floats 4s instead of vectors. And we want to clamp this of our position value x on our game data dot bounds dot x and our game data dot bounds dot y. Remember, x is our left, y is our right bounds. So that's that should give us now a system where the player can never leave the play space, right? The bounds of our world is defined. Let's go make sure that works. And we have a bug because we should not be over here. And we can see that our translation is hard coding us to 9.5. And why is that? Let's take a look at our game world. We have, and if we look here, that makes a lot of sense. We set the minimum, the left side to 9.5, and we set the right side to 9.5. So we're clamping between those two numbers, which can only be 9.5, which is on the right-hand side. I need to go back in here and put a negative value there so that we are negative 9.5 to positive 9.5, because 0 is center in our world. 0 is the center, so negative to positive. So now we're going to spawn and we're still in the center. And if I move left, I can't move any further left because we're clamping that axis to the bounds of our world that we have custom defined, right? So now I can move left, I can move right, and everything in the world is right.